How can we mitigate issues around these large models generating emissions? And then what are the more promising AI-driven solutions to climate change?
Thinking about it, training time, thinking about it at inference time, as you mentioned, and then also how this whole ecosystem kind of also connects to sort of general access to models. The biggest thing there that's really helpful is having renewable energy drive a lot of these, the cloud services that are actually powering these systems. With GPT-3, we really wanted to just build this very powerful model and see what it could do.
Melanie, thank you for coming to Manhattan and filming this episode with me in person. I'm so excited to film it. I've been excited about it for weeks. So your journey here was pretty easy, right? You live in Brooklyn?
Yeah, it was nice to just come over here for the day.
Nice, and it's a beautiful day here in New York. If you're watching the YouTube version of the episode for the first time ever, I'm filming with my windows open. Hopefully there isn't too much street noise, but it's just a beautiful sunny day here in New York. Spring seems to be on its way. All right, so I know you through Claudia Perlich. She was in episode number 437 of the podcast, and she was alongside you in a Wired video on explaining machine learning at 5 difficulty levels. So that was hosted by Hillary Mason, and it's a great video that I highly recommend to listeners to check out anyway, because whether you are a practicing data scientist looking for a way to be able to explain what you do better to people at cocktail parties or family events or whatever, or whether you're just getting into data science and you want to learn about what machine learning is, Hillary speaks to an elementary school student, a high school student, a grad student, and an expert. That's only 4 levels, so I'm missing one.
The undergraduate also.
An undergrad as well. So elementary school, high school, undergrad, grad school, and then, so the expert was Claudia Perlich, and you were the grad student.
Yes.
And we'll get to the grad student thing later, but from the very beginning, I was like, this is no ordinary grad student. It doesn't seem like, in a lot of ways, as will become clear to the listener immediately, you are also already a deep expert who happens to be in grad school. So we'll talk about that more later in the program. First, let's dig into how you're definitely an expert, which is that prior to going back and doing your PhD, which you're doing now, you worked at OpenAI. So OpenAI is renowned for being one of the top few AI research centers on the planet. Big names like Ilya Sutskever, who came up with AlexNet. He was one of the 3 authors on the first AlexNet paper. Peter Abil, who's a famed roboticist and entrepreneur, and he's in episode number 503 of the show. Ian Goodfellow, who came up with generative adversarial networks. These are some of the amazing people who have worked at OpenAI. And it's also pretty well known because it was founded by Elon Musk and Sam Altman, who is the former president of Y Combinator, and other well-known people. And it's produced lots of front page news innovation. And I don't just mean machine learning news, I mean in the Times and the Post and the Economist. I feel like I'm constantly reading about new innovation from OpenAI. So for listeners, for practicing data scientists, something that's really cool is OpenAI Gym, which is great for reinforcement learning research. But then in terms of stuff that's made a big splash in the popular press, there's DALL-E, which is really cool for generating art based on natural language input. I've had so much fun with that tool. But perhaps the most famous innovation of all to come out of OpenAI is GPT-3. And you, Melanie, worked on GPT-3, and you were a joint lead author on the first paper on it. So unbelievably lucky to have you here with us.
Thank you. I'm really excited to be here and talk to you as well.
Awesome. So what does GPT stand for?
So GPT stands for Generative Pre-trained Transformer Model.
Nice. And then this is the third, I guess, third major release of GPT.
Yeah. So there was an original GPT paper, then there's GPT-2, and then GPT-3, which were all sort of based off of the same framework, but increasing in power and complexity of what they're able to do.
Nice. And so a key word in there is transformer. And so the other words are actually relatively easy to understand. So generative, it can generate text.
Yes.
As part of its outputs. And pre-trained, meaning that it's already trained. You don't need to necessarily train it. So transformer is really the only word that could be complicated. So what is a transformer and what's a transformer model?
Yeah, so transformers are a really popular architecture in NLP right now, and they basically came about to address some of the challenges that people had with recurrent neural network architectures. And so two of the big advantages with a transformer model is that it allows the model to learn from previous context in the text very well, going back pretty far. So you can have a long input context. And it also allows you to train the system in parallel across many, many GPUs, which lets you scale it up to huge data sets, a huge number of parameters, which is part of a critical part of the success that we've seen with these systems. And a key part of the transformer is that it relies on attention. And so basically the model is learning weights to apply to different parts of the input in the input context to figure out what word to generate next or what output to generate next based off of which inputs are most critical.
Nice. That was very clearly explained.
Okay.
And so to kind of recap on some of that, so a problem with the predominant natural language processing architecture prior to attention and transformers, so things like recurrent neural networks, long short-term memory units, is that the signal of information from preceding words or words ahead of a given word of interest, it decayed very quickly. And so, roughly with recurrent neural networks, it was like after 10 words, the signal from the word 10 words ago is kind of lost. It can't really have an impact on the current word. And so attention and transformers overcome that issue and allow it to, consider a broader context like you're describing. And this is critical because when we speak or when we read as humans, just 10 words back isn't enough to understand the context of what's going on.
Yeah.
So these kinds of previous approaches, like RNNs, recurrent neural networks, long short-term memory units, LSTMs, they were not very capable at this kind of few-shot learning that GPT-3 has proved to be very good at. So few-shot learning is a situation where you could say something like, so the input to GPT-3, you could say, translate English to French, and then give 3 examples. So you say, translate English to French, and then you say, dog to chien, and cat to chat. And so you give 3 kinds of examples, and in that kind of situation, it looked like GPT-3 is more than 50% accurate in that kind of few-shot learning situation. And then even if you go to one-shot or no-shot, so if you say a one-shot example would be where you say, translate English to French, and then you just give it one example, dog to chien. So that's one-shot learning. And no-shot learning would be where you don't give it any examples. You just say, translate English to French, dog, and you expect it to output chien. And so I think as we go, and you can correct me if I'm wrong, but as we go from few-shot learning, where we're more than 50% accurate with GPT-3, as we go to one-shot and then no-shot, the accuracy does go down.
Yeah.
But the huge innovation is that on this few-shot learning, GPT-3 absolutely crushes any pre-existing architecture.
Yes. Yeah. Yeah, it was really the first time that we were able to see any sort of successful few-shot learning from this type of paradigm. It's really exciting because it's much more similar to how humans actually perform tasks, where we can just give each other instructions, maybe a couple examples, all in natural language, and then we're able often to do a new task just through that simple instruction.
Yeah, so that's a big part of the pre-train part, right? Is that the idea, I guess, with an architecture that is so large and is trained on so much data that takes advantage of transformers, that you don't need to train it to a specific task. It can perform translation like I just went through. It can answer questions for you. It can do simple arithmetic.
Yeah.
And so that kind of diversity is a really amazing new thing that is emerging in these kinds of large transformer architectures. So that kind of task, that ability to be able to perform so many different tasks is that almost like an emergent property that you're like surprised when you discover, wow, I can also do this? Or does some of the design thinking revolve around, okay, what are the kinds of big natural language tasks out there? Question answering is a big one. Translation is a big one. Let's deliberately try to design an architecture that can do it. So I guess the question is it mostly just emergent that it does all these things, or do you have to design specifically to be able to be so broadly applicable?
Yeah, that's a great question. I think there were kind of two stages. I think actually building the model, most of these properties were very much emergent things. Like in the GPT-2 paper, we started to see hints that the models like this might be able to do this type of thing, but the performance really wasn't that good at that stage. And so with GPT-3, we really wanted to just build this very powerful model and see what it could do. And I remember being there at the time. It was really exciting because every week it would kind of be like, oh my gosh, someone saw this new amazing thing from the model.
Wow.
So it was very much a surprise to many of us. I think also just seeing it perform across a bunch of these tasks. And if you look at the results in the paper, also there's certain cases where since we train models at different sizes, you'll have a smaller model that really couldn't do anything on a certain task. And then there's like a sudden jump when you scale up to a certain size where suddenly you have traction on that task. So there's also things that we haven't even seen that could emerge with larger models as well, which is very exciting. So that's the part that sort of was not really designed into the model at all. I think the part, though, that does take some engineering, which is a lot of what I worked on as well, is we wanted to kind of just throw as broad a suite of tasks as we could at the model and just get a general sense of what can it do, what can it do, and that we were looking to these sort of standard NLP benchmarks and data sets. But within this few-shot paradigm, you do have to formulate that prompt to the model, so it matters a little bit, like how do you phrase the instruction, how is it getting tokenized to the system, what examples are you using? And that's something we didn't over-engineer at the time, but a lot of people have continued to look at since then, which is really exciting. But that was one thing too that we did notice variations depending on sort of how that prompt was formulated sometimes. And so that was a part where we were kind of looking at a specific task and how the performance looked on that task.
That ties perfectly to my next question, which was going to be, when does GPT-3 struggle? So are there particular kinds of circumstances where there's patterns that you're like, these kinds of inputs, it's going to do really well. These kinds of inputs, even on a similar task, it's going to fall down.
Yeah. So one data set that we had, we struggled with when the paper came out was ANLI. There was sort of like almost random performance on that, which is a natural language inference task.
What does that mean?
So that means basically kind of inferring the relationship between two phrases and whether there's like entailment between those two events. So it's kind of getting into causality and reasoning. And that's another thing with sort of multi-step reasoning can be a little bit hit or miss.
Right.
For example, if you like set up a scenario and it's like, I put 3 glasses on the table and then like Jon comes in and takes 2 of them away, like how many glasses are still there? And I think with things like that, as you get into more complicated sort of levels of logic, it can be hit or miss.
Right.
Yeah.
99% of machine learning teams are doing awesome things at a reasonable scale, with say about 4 people and 2 production machine learning models. But most of the industry best practices that we hear about are from a small handful of companies operating models at hyperscale. The folks over at Neptune.ai care about the 99%, and so they are changing the status quo by sharing insights, tool stacks, and real-life stories from practitioners doing ML and MLOps at a reasonable scale. Neptune have even built a flexible tool for experiment tracking and model registry that will fit your workflow at no scale, reasonable scale, and beyond. To learn more, check them out at Neptune.ai. That's Neptune.ai. And I'm really relieved that that's true at this stage.
Yeah.
It's like, I think there were a lot of splashes made when GPT-3 came out that, oh, this whole news article was written by a robot. Mm-hmm. But then when you look at the fine print, it was like, well, we gave it 10 tries. Mm-hmm. And then we edited it. Mm-hmm. And then the editor was like, but we do that with human writing as well.
Yeah.
But I'm like, yeah, but are you editing out stuff that just seems like completely random? Or that like a human would never write, which I think is inevitably true.
Yeah.
So obviously these systems are incredible at the capacity to be able to sometimes, or even the majority of the time perhaps, generate really compelling text. But yeah, as things get more complex, and I think even with these transformer architectures, the further away the language is in a given document, I think the more likely it is to be unmeaningfully related, right? Like,
yeah, like the further you get out in the generation.
Yeah, exactly. Like, so in adjacent words, it's almost guaranteed to make sense.
Right.
You know, if you look at a string of 5 or 6 words, they almost always make sense. But if you look at 2 or 3 sentences in a row, maybe much of the time it does make perfect sense, but some of the time it doesn't. And then if you look over multiple paragraphs, and then it starts to stretch things.
Yeah.
Right? So a term that I came across as I was researching this episode a lot, and that I didn't know a ton about, and I'd love to understand better, is an autoregression. So what does that mean?
Yeah, so usually we think about autoregression in contrast to bidirectional systems. So autoregressive systems are learning from a previous sequence to predict what comes next, whereas bidirectional systems can use sort of both future and past information. So a great comparison here is BERT, another hugely famous NLP model, is bidirectional. So it can learn from everything within the model's context, so both text that comes before and after, or maybe just like the whole paragraph or the whole document. Whereas with GPT, or the GPT series models, you're always feeding in some sequence and then predicting what comes next. So
Got it.
Those two frameworks kind of lend themselves to different problems. So using a bidirectional system can be very good for like document classification, or maybe reading comprehension questions where you're sort of processing something as a whole and then answering something about it. Whereas using the autoregressive framework is what really enabled this type of few-shot paradigm, because you can kind of feed in that input and then generate forward some sort of output.
Nice. Really good explanation. You do have a knack for explaining things very clearly. Cool. So changing the topic just a little bit, I mean, still staying on GPT-3, but an original strength of GPT-3 was the breadth of natural language capability that we already talked about, that it is pre-trained, the P in GPT-3.
Yeah.
So that means that without doing any model training, without updating any gradients in the model, we can have it apply, as we already described, to question answering, to simple arithmetic, to translation.
Yeah.
Now, interestingly, in December, OpenAI nevertheless made it possible to fine-tune GPT-3. So you can fine-tune it now to your own data with a single line of code using their API. So how does this transfer learning work, and what is the practical impact? So if GPT-3 was already capable of being so broadly applicable, what additional advantages are afforded with this new fine-tuning ability?
Yeah, that's a great question. So we still live in a world where few-shot is kind of this ideal scenario, but in most cases we haven't closed the gap between few-shot performance and fine-tuning. So if you look at the results in the paper, the few-shot performance is very good, and in some cases it is kind of up there at human level, but in many cases it's kind of good enough and exciting in an academic way, but if you actually applied it to a real-world business use case, it would still have sort of too many failure cases.
That was Peter Abiel in his episode. We focused a lot on deep reinforcement learning applications to industry.
Okay.
And he was describing that one of the biggest differences is that, relative to academia, is that in academia, you're trying to get, like, even just once, being able to get a robot to do something really crazy.
Yeah.
But in production, that doesn't matter at all.
Right.
So in production, you're working at having robots become good at a task that maybe was interesting in academia 5-10 years ago, but doing it at extremely high accuracy. So that kind of sounds similar to what you're describing.
Yeah, I think that's a great way of putting it. So I think with that, if you can achieve greater performance with fine-tuning on your business use case, you definitely want to do that. And beyond that, also, this starts to get into thinking about bias and safety around language models, because part of why you may want to fine-tune also is to work with the specific data for your use case, and to kind of guide the model towards the types of responses and the range of responses that you're actually comfortable with in your application.
Nice, that makes sense. And I was reading that it seems like in some cases, even just having 100 examples in your additional data set for this transfer learning could be effective. And in case I didn't define this term, transfer learning is where you take a big pre-trained model already, like GPT-3, and you fine-tune it. It's called transfer learning. All right, so I was going to ask you this question later, but since you mentioned bias, I'm just going to jump to it right now. So OpenAI's former VP of Research, Dario Amodei, admitted to GPT-3 performance on bias issues in some of his slides that we found online. And so we'll provide a link to those in the show notes. And so part of this can be related to that men from developed countries are overrepresented as authors of online content, especially in the content used to train most language models, including presumably GPT-3. So this can lead to models picking up on biases that disadvantage other groups like women and people that just aren't from developed countries, for example. What can we do to mitigate dataset bias like this?
Yeah, it's a really important issue, and unfortunately a reality just given that the models consume so much data and the only available source of that is kind of this very uncurated online world. And so I think there's a first really important component, which is just trying to study and understand how the model is performing and document that as well as possible and share that information and be transparent so that people are aware of the risks and understand what's going on with this system. So that was a big thing. As we were releasing GPT-3, OpenAI has a whole policy group, and that I worked with some of our researchers there as well on building out these bias tests for our system so that we could try to kind of be transparent about what we were seeing from the model. And as you're saying, in most cases, without kind of further intervention, these systems do replicate just the average of what's online, which is not representative of the average of the world. So I think that's a really important thing at this stage is giving that information to people who are using these systems. And then the second stage is also enabling them to kind of do something about that in their specific use case. And so there was a paper from OpenAI that worked with fine-tuning, as you mentioned, and kind of just small data sets of 100 examples to guide the model towards the type of output that they were looking for on specific sensitive topics. And they found that they could definitely move the needle in a good direction using that type of approach. So I think that's one way to go. Ultimately, I mean, ideally, we would have great data that people could sort of collect as much data as they needed that fit their sort of standards for their particular use case. But I think we're not in a place right now where that's realistic. So for me, at least, I tend towards be really transparent, have very honest conversations about what is needed in a specific situation, and then really test the system and see whether it's going to be up to your standards for that.
Right, and it sounds like there's something that every listener can do at home to make this situation better, is don't be a dick online. And that'll help in the long run.
Yeah.
All right, so thank you for answering that question on bias. Really great, clear answer. So something that you mentioned earlier on, there are so many jumping off points for the conversation. And so something you mentioned earlier that I want to come back to is this idea of how as you increase the number of parameters, on some tasks, you would witness this big jump in performance. So few-shot learning, maybe on translation, at the actual number of parameters that GPT-3 has, which is 175 billion parameters, and that's 2 orders of magnitude more than GPT-2 was. At that level, we're able to get this great few-shot learning performance. So other people are taking this idea and expanding it further. So in 2021, there was a Chinese group that released WuDao 2.0, which is a model with exactly an order of magnitude more parameters than GPT-3. So GPT-3 has 175 billion parameters. WuDao 2.0 has 1.75 trillion parameters. And it was able to generate compelling Chinese poetry, for example. So over the coming years or decades with GPT-4, GPT-5, WuDAV 3.0, whatever, are we likely to need several more orders of magnitude to reach human level language capability? And as a kind of a reference point, the human brain, one human brain, has about 1,000 trillion synapses, which in a loose, very, very, very loose way, because there's all kinds of nuanced differences between biological neurons and artificial neurons like we have in these architectures. But loosely, we have 1,000 times more connections between biological brain cells in a human brain relative to the number of connections between artificial neurons in WuDAV 2.0. So, so I guess I've already asked the question, but it's basically, do we need to keep going down this route of increasing parameters to get closer and closer to human level ability on language, or are there other potential avenues to explore?
So I think the increasing model size is sort of the avenue that we've seen actually work in this so far. And as you're saying, like there is still this big gap between how big these systems are and how big our brains are. And so I think it definitely feels logical to kind of continue scaling up these models as long as we're seeing these returns.
Yeah, especially because it works. Like as you said, in examples in the GPT-3 paper that you co-authored, you look at these charts of performance and it's like, as we increase parameters, performance clearly goes up. So, I mean, naturally, you're going to think to keep going.
I think the important caveat to that is that there's definitely something we're doing wrong or not in the most efficient way, because when we think about the sample efficiency, and so by that I mean how many words, like how much exposure to language someone or the model needs to be able to use language proficiently. And for humans and babies and young children learning language, that the amount of language that they're actually exposed to is very, very small compared to what we would consider like small transformer models are trained on today. So that's, I think, something I definitely think about is I expect that in the future we'll figure out a more intelligent way to do this where we can actually learn more efficiently from a smaller amount of language. But I think given where we are now and what we're seeing work, it seems to be very effective to continue scaling systems as we have data available and compute available to do it.
Being able to interact with the amazing guests we have on Super Data Science is the best part of my week. The only thing that would make it even better is if I could share the experience of filming episodes with you live in person. Well, fantasize no longer, because on March 31st at MLconf New York, we'll be filming a Super Data Science episode live and in person for the very first time. That's at MLconf, the Machine Learning Conference. I'll be interviewing a global deep learning leader, and there will be a dozen other exciting talks from prominent machine learning experts. Held at a gorgeous rooftop venue in central Manhattan, MLconf has long been a special annual event for me. I can't wait for MLconf on March 31st, and hopefully I'll get to meet you there too. Head to superdatascience.com/MLconf for all the details and a 30% discount. Again, that's superdatascience.com/MLCONF.
Yeah, so something that I didn't have written down as a question, but just came into my mind as something that I'd love to pick your brain on, is currently almost all of our leading approaches, whether we're talking about natural language, machine vision, robotics, all of the leading AI applications today that I'm aware of, they tend to involve deep learning, but they almost always involve gradients. So some kind of function that we can differentiate and do partial derivative calculus on. But that obviously isn't, well, some people actually do think that that is how biological brains work in a way, or that at least it is a model for how we learn, but I don't know, that's certainly contentious. However, a big difference between the way that we think about how we store information in human brains versus these differentiable machines that require gradient learning is that we can have like semantic linkages between information. Like we can have, you can have an idea of the relationship between the meaning of words, like a hierarchy. Like all of these things are examples of a person. And so this kind of explicit representation of knowledge isn't something that you can easily differentiate over or at all. So I guess, just kind of broadly speaking, do you think there's a place for non-differentiable information storage in future natural language models?
Yeah, I definitely think there is a place, and I think that's a huge debate right now, kind of whether people who are very much in a camp of we need more structured approaches and things that are very much built off of sort of our knowledge of human language systems and how we learn versus approaches that are more sort of, let's use more data, more compute, and engineer our way to kind of a solution that works from that standpoint. I think there's definitely, I think for me, I'm very kind of open intellectually to what future models might look like, and I think there could be a place for that. I think I'm hesitant to sort of dramatically move away from something that's working very well and trains very well and scales very well.
Why would you stop right now?
Yeah, because I think that component of scale, like being able to easily take advantage of more data, is something we've just seen work over and over again in terms of improving performance on something. But I think there is, we're definitely, I feel that we're missing, like the transformer architecture, I don't think is the be all end all of NLP. I think we're going to continue to figure out tricks. And I think something like incorporating memory is really important because, as I was saying before, you are still limited to the context that you can feed into the model and how long that is. And so we do at some point have to incorporate some sense of memory or world context beyond just like that page or document that you can sort of feed into the system. So
right.
Yeah.
And then that could potentially maybe be a step in the way of having models actually be able to make logical conclusions. So that kind of natural language inference that you were describing that models currently struggle at.
Yeah.
Cool. All right. So as I was researching for this episode, I discovered that you're into human creative writing.
Yeah.
Not just generative models.
Yeah.
And so you've done workshops in Ireland.
I studied abroad
there
and did a writing program there. Yeah.
And so you're probably aware that GPT-3 is used for creative writing.
Yeah.
It's a common application, actually. And it's even been commercially deployed for copywriting. And I'm going to provide some links in the show notes to articles that show examples of these commercial deployments of GPT-3 for creative writing purposes. So I can probably kind of guess where your answer is going to go with this, but maybe you'll surprise me. So as each successive GPT model, GPT-2, 3, and then some future 4, substantially outperforms the previous, does this eventually spell doom for your human creative writing interests?
I think, to me, it's more exciting than scary, I guess. That was actually how I first got into NLP and AI. I was in my senior year of undergrad, and I was trying to think, how can I combine writing and computer science for some sort of thesis? So I was like, okay, I'll build an AI that can try and do creative writing.
Cool.
And at that time, I was working with LSTMs, and it was a struggle to get even like 2 sentences out that were coherent and sort of creative. And so that really just blew me away. Like originally seeing the GPT-2 paper even come out and just seeing like a paragraph of pretty much coherent creative text. And I was like, wow, this is so cool. So I think I've always had more of that kind of just like, this is very exciting perspective. And I think for me, I envision much more of a world where humans and these creative AI systems are collaborating, and it's almost more like if you're in a writing workshop, you're reading and writing with other people and kind of bouncing those ideas off of each other. And I think there's really cool opportunities for these creative systems to be almost like idea generators, or they could be kind of standalone works. But I think there's always going to be something different. Like part of a story is sort of the intention behind it and the feeling that's being communicated. And I think there's always going to be something unique about that from the writer, so it'll be unique whether that's from an AI or it's unique if it's coming from a specific human or that's my perspective. Yeah.
I love this idea of some future, when we're beyond transformers, we have some non-differentiable component and we have this model that's like, you don't know what it's been like for me, man.
Yeah. I guess that's if the system could just like totally replicate you, then I guess that would maybe make me feel not so great, but
no, I mean that the system on its own has like its own, in the same way that like some writer today is tainted by some high school breakup or their parents' divorce.
Yeah.
You have like machines that are scarred by some.
Right, they're gonna have some backstory that they
Exactly.
created. Yeah.
And every book that they write kind of has that same tint to it.
Yeah.
Fun. All right. Well, I'm glad I asked you that one. It's super cool to hear the connection there between your creative writing and computer science. And it's cool. So probably around the time that you were trying to make LSTMs create one or two coherent sentences together, that was probably around the time that I started teaching deep learning. And so I was similarly, a common project that I would have my students do was take an LSTM architecture or a gated recurrent unit architecture or experiment with different kinds of these recurrent architectures and see whether you could get some text to make sense. And the thing that we settled for back then was, I'm sure you remember this, something that was very common is that people would have it generate Shakespeare. You train it on a Shakespeare corpus and have it generate Shakespeare, because no one understands what Shakespeare's saying anyway. So if you have Shakespeare-style content coming out, you're like, I guess that sounds like it could be the Bard.
Yeah.
It's close enough. I don't ever understand what he's saying anyway, and I don't understand this, but it seems to be in his style. So we really have come a long way now with GPT-3. So yeah, so cool that you saw GPT-2 as you were, working at that age, and that you were then later able to make your way to OpenAI. And so I was going to ask these kinds of questions later, but it seems like we're at a good point in the conversation. So how did that end up happening? So you're doing an undergrad in computer science, you have this creative writing interest, and then after that you went to Apple, right?
Yeah.
So that kind of makes sense. I mean, you can tell us, but I imagine, Apple is one of the most exciting competitive companies to work for. So you're probably like, applying to amazing places you could work, and being able to be an AI research engineer there sounds like an amazing experience. So maybe tell us about that, and then how you ended up after that at OpenAI.
Yeah, so I went to a liberal arts school for my bachelor's, and so it was a wonderful school, but there weren't that many
Williams College.
Specific computer science classes. So I actually graduated with like the fundamentals of computer science, but I hadn't taken an AI class, an NLP class. I did this thesis and mostly just read papers myself that was in machine learning, but I didn't have any kind of education in that at the time. So when I was looking for those first jobs, I actually wasn't hired as an AI research engineer. I was hired as a computer graphics software engineer, but I picked a team in special projects there where I knew I was going to be close to all these other research teams. And I basically just started going to paper reading groups there and like making connections with the researchers. And then as things sort of shuffled around, I kind of volunteered myself for projects and then was able to like switch on to one of their AI research teams pretty quickly. So that was a really cool opportunity because it gave me exposure to a bunch of different things in the space, and I could kind of try out things. And I narrowed in on like, okay, I really do like doing machine learning and AI, and was able to get onto one of these research teams without sort of having the education at that point. So that was a really busy couple years because I was mostly like reading textbooks and papers in my free time after work to sort of teach myself all of this curriculum on deep learning and ML and try to get up to speed with what I was doing with my team. So yeah, I was actually in like doing some more robotics and computer vision and RL, and then sort of circled back to NLP while I was there. And around that time was when GPT-2 came out, and I'd sort of been there long enough where I had the confidence then to say like, okay, actually, I really want to apply to OpenAI because they'd also been on my radar. Just I really liked the mission of the company and what they were trying to do in the AI space, so I wanted to try
something
that out. Yeah.
That I didn't mention when I first started talking about OpenAI is that they were originally created as a charitable organization, and their mission was to bring about artificial intelligence applications in an ethical way. That was kind of the modus operandi of the whole organization. Now they do have some commercial revenue streams. Yeah. And actually, one of the things that's most annoying about that is it used to be cool because they were a charity before. They had to publish everyone's salaries. Yeah. And so you could see like, oh my God, that's what Ilya Sutskever is making and that kind of thing. Yeah. And so that was a fun thing that's now been taken away from us. But yeah, so you were attracted to the mission of OpenAI. I mean, yeah, super cool organization. And then I wonder, was also part of what drew you those experiences during your undergrad where, seeing the GPT-2 advances? Yeah. Wow, yeah, cool.
Yeah, for sure. Yeah, I think just seeing that paper come out was sort of, wow, this is exactly what got me so excited about this field, and I'd love to work on systems like this. So I transitioned over to work with them at that point, and I didn't know that they were working on GPT-3 at the time, or that that's what I would end up working on. But
wow.
Yeah, it ended up being this great team. I really enjoyed the team I was working with there on that project, so that was a really fun year and a half. Yeah.
Nice. So kind of a general question for you that might be helpful to listeners is, it sounds like part of how you were able to make this transition, whether it was from the undergrad to Apple or Apple to OpenAI, was a lot of self-study.
Mm-hmm.
So how do you go about that process? How do you identify what papers you should be reading? And then, how do you just stick to it, especially if, there isn't the feedback of a formal study group or people to talk about these papers with?
Yeah. I think it definitely helped having some sort of peer motivation, like having a research group that I was going in and maybe like presenting a paper to each week, or having, I needed to have something to say.
Deadlines, classic.
Right, definitely gave me motivation to kind of actually read that and prepare. And I think early on, having people that you look up to who are sort of recommending papers, and that can be people on Twitter or people in your immediate sphere. And once you get a couple, then I think it's very easy to just like go forward and backward in the citations and try and fill in the gaps, like just circle things you don't understand and then go back and research what actually is going on here. Because I think it's actually, I feel like a lot of times when people read papers, you are sort of skimming over a lot of the math or a lot of the information. And ideally, as you become an expert in something, you can kind of follow that very quickly and fill it in. But I think that was important for me early on, was actually like stopping at every point I didn't understand and trying to put together that math or go back and fill in a citation that I needed to understand. Also just finding textbooks and then kind of just giving myself like, okay, I'm going to read a chapter this week. I think that's maybe unpopular. I feel like a lot of people don't like textbooks as much these days, but I actually like that. Yeah.
I mean, I do write books, so I'm definitely biased. Yeah. But part of why I enjoy writing books is that because I have had so many incredible experiences from working through books. Mm-hmm. Because unlike a paper, a well-written book has somebody who's thought about a huge body of stuff and can tie it all together coherently. And so a good book can be a big game changer.
Yeah, for sure.
And it can expose you to things that you might not otherwise have ended up studying. So when you do that kind of process, maybe chapters 1 through 3, you were like, that's exactly what I want to do. And then 5 was also what you want to do. 4, you're like, I don't know, but I've really enjoyed this author for the first 3 chapters, so I'll check it out. And then you're like, wow, I didn't even know this was relevant to my interests, or I have this whole new interest now.
Yeah.
So I love books.
Yeah.
On your point of people to follow on Twitter, so if listeners don't have somebody that they can talk to about what papers they should be reading, I did an episode number 530 on 10 AI thought leaders to follow. So that could be you could get some ideas of who to follow potentially from that episode. Something else that I took away from what you just said is that it sounds like the trick, as with most things, to being really good at something is just a lot of work.
Yeah.
You put the time in.
Yeah, that's definitely true.
All right, so once you're at OpenAI and you discover you have this opportunity to be working on GPT-3, that must have been amazing. But you also, while you were there, you worked specifically on the OpenAI API that allows people outside of the organization to access GPT-3. So how is having an API interface like this useful to people, and how can they access it?
Yeah, so the idea of the API is that people who maybe don't have the expertise with building these systems, or just don't have the resources to build models like this, are able to kind of easily benefit from the technology. And so it was designed to be sort of a very simple interface where you can interact with it through natural language, which is, the whole idea of few-shot learning, as we've talked about, and kind of just be able to give it very simple instructions and prompts and get your generated output back. And all of the compute, all of the engineering is kind of handled on the OpenAI side. So you're just paying for a subscription service, basically. And now, as you mentioned, there's sort of added bonuses of fine tuning or different things. And so you can kind of be closer to the engineering if you want to, but it's also okay to be someone who is less comfortable with that and more comfortable working through the natural language interface. So
that actually makes it probably an unprecedented API in the sense that you can ask it what you'd like it to do in natural language.
Right. And that was really the goal with, or what we realized with this few shot learning and actually being able to have this work pretty well is that it does enable this type of technology in kind of a new way that we hadn't seen before.
Cool. Yeah, so it's conceivable that in the future, probably not even in the distant future, if you're okay with some inaccuracies, you could have a system like this working for somebody who has no programming experience at all via an audio interface.
Yeah. Yeah, exactly.
All of the technology for that exists. You could there already exist algorithms that at a very high accuracy, like Siri on an iPhone or any Apple device, will convert the audio waveforms into text. And then once you have that text, it can go into the OpenAI API. And then the API can bring you back results, but then why not speak it? Because we have that technology too.
Yeah.
So, wow. Cool. Speaking of inputs and outputs, in addition to GPT-3, the API access also provides you with access to codecs, which converts natural language to code.
Yep.
So how practical is that? How often does that actually work properly?
So that portion of the API came up after I had left OpenAI and gone to grad school, so I don't have personal experience with it. I think I'm really excited to see where that kind of technology goes, because I think there's a lot of daily programming tasks that, at least for me as a programmer, I will Google something, find someone else who wrote it, and fill that into my code with maybe some modifications. And I think that's that's sort of the idea of codecs, is kind of like skipping that Google step, that you can kind of like fill in this stuff in your code that's like pretty standard, used across a bunch of different use cases. And again, sort of like what we were talking about with creative writing, like having that tool, that pair programmer that you can work with, that's sort of very good at specific things.
Cool. I love that idea of a robotic pair programmer friend. Yeah, that sounds really helpful. Okay, so now getting into another one of those tricky questions around these big models. So we talked about the bias issues, kind of a big one that comes up. Another one also related to one of your interests. So I know that you're interested in using AI to tackle climate change.
Yeah.
So we have actually done an episode on AI being used to tackle climate change. So listeners can listen to episode 459 for kind of like an hour on that topic. But something specific to that for you is that these huge models like GPT-3, for every additional model parameter, there's a little bit more energy that's required.
Yeah.
But when we're talking about hundreds of billions or trillions of model parameters, to train these models on large data sets, and then even at inference time, the impact in terms of climate change is non-negligible, especially as these potentially become more and more popular. So AI is increasingly a contributor to carbon emissions. On the flip side of that, insights from AI could be providing solutions to the climate crisis.
Yeah.
So what do you think about this in general? How can we mitigate issues around these large models generating emissions? And then what are the more promising AI-driven solutions to climate change?
Yeah, that's a great question and a big issue. And yeah, I think there's kind of thinking about it at training time, thinking about it at inference time, as you mentioned, and then also how this whole ecosystem kind of also connects to sort of general access to models. And I think with the training, there's the good news is that typically as we go forward, compute gets more efficient, cheaper. And so what something looks like right now, 10 years from now, it's not going to consume the same energy to train that system. But we're also probably going to have bigger systems. So that's kind of a tricky situation. So I think that's one issue. And I think the biggest thing there that's really helpful is having renewable energy drive a lot of these the cloud services that are actually powering these systems. So like Google is doing a great job of moving a lot of their compute in a really good direction in terms of renewables. And I think that's something I hope we can be really successful with that in the next kind of 10 years. In terms of inference time, I think so a lot of these models are actually much more efficient to run at inference time. So once you've trained it and you're querying it for different outputs, that can be pretty efficient. And you also can engineer the system in a different way so that it's actually running very quickly and in a very efficient way at that point versus how you trained it. So I think that's another thing that we can do is like separating out those two use cases so that you are making it as efficient as possible when you're running it into the future. And the last thing is thinking about how this affects kind of democratization of AI and access, because I think something we talk about is like there is this issue where only a few groups have the resources to train models like this, and then they have kind of the dominant access to those systems. And so in some ways you might say, oh, ideally like everyone could train systems like this, but then suddenly we're replicating these hugely compute intensive models across many different groups, and that becomes very wasteful of energy. So I think it's going to be really important to move towards some sort of coordinated system where we can both only train a model once and then let everyone use it, but we're not kind of like hoarding access so that some people are totally shut out from something. And I think that's a really hard line to walk. Like we want people to be able to research these systems, use these systems, but we also don't want to kind of overly replicate things that are very resource intensive. So that's something I think about a lot. I think then going into ways that AI can help with climate change, I think two things I'm really excited about are energy efficiency and kind of thinking about intelligent grid systems and just intelligent use of electricity. And I think that will also help with incorporating renewables better. If we have a better understanding of forecasting and how to integrate all these systems, it could save a lot of waste within our energy grid. So that's one thing I'm excited about. And then also thinking about the materials discovery space. So using AI can kind of speed up discovery in a bunch of different scientific areas by speeding up simulations that people run to sort of figure out what might be promising directions to explore.
Right.
And I think we're starting to see applications like this used in carbon capture or battery technology or things like that that are going to help us have, again, like more sustainable systems across the board.
Very cool examples. So we'll ask GPT-6, draw us a schematic of how we should design the tokamak reactor for a nuclear fusion energy production that exceeds the amount of energy we put in.
Perfect.
Nice. It'll be easy. So it's really just a natural language problem.
Yeah, when you put it that way.
Okay, cool. All right, so you've answered all my tricky questions flawlessly. Nicely done. So when you're working at a place like OpenAI, working on things like the API, developing transformer models like GPT-3, we also talked about things like DALL-E. We talked about the OpenAI Gym. So many different, completely different kinds of innovation. And so what's the culture like in a place like OpenAI? And you were largely there, if not entirely there, before the pandemic hit. So you're probably in office with people. So yeah, what's that like? How do they bring about so much diverse innovation?
Yeah, I think it was a really cool environment to be in. And we were a pretty small office when I was there, so it was really nice. I was just kind of like sitting with my 5-person team. And I think two things that really stood out to me about the culture there. One was that there was a very clear research vision so that people were very collaborative around it. And there was a big engineering focus to support that vision. And I think that was different. A lot of the other research environments I've been in have been more separate projects that kind of like 1 to 3 people are working on, and you kind of connect the things under a bigger vision, but it's not as much top down of like, this is really the goal we're driving towards, and let's like build out these big research efforts under that. And then also having that engineering support was huge. So a lot of people at OpenAI started more as engineers kind of similar to me. And I think especially when you're building systems like GPT-3, like DALL-E, a huge amount of that is solving engineering problems at scale also and keeping these systems running efficiently. So that's another big component. And then the last thing, which is more of like a day-to-day thing, is that that's really the only work environment where I've been in where pair programming was just like very common. So especially when I was starting and I had a question, one of my coworkers would just be like, let's pair on this for a couple hours this afternoon. And that's something I really appreciated because you just learn so much from watching someone else do something, and you also just get through questions much more quickly when you can just like solve it together, as opposed to sort of asking something and then you go back to your desk and you find out it's slightly different than what the person said, and then you're trying to figure it out. And it's so it was very much just like, let's work together quickly around this united vision and do the best that we can on that.
Yeah, that sounds great. So on the note of talking about engineering support and how many people at OpenAI come from engineering backgrounds, this is a recurring theme on the show, and something that I have tried to impress upon listeners before, and I'm going to again now, is that the engineering aspect of data science, every year that goes by, is even more important.
Yeah.
If you want to make a big impact in your career in data science, especially in AI, the more that you can learn computer science and programming principles and find somebody to pair program with, the better off you're going to be. Because as data sets get larger and larger, as the models get larger and larger, it becomes more and more of an engineering problem than a science problem.
Yeah.
And then something that I've also whinged about on the program recurringly is that so I have been proved wrong in general about working from home. I thought that it wouldn't work for research. My team does AI research and a lot of it is open-ended. And I thought that we needed to be together with a whiteboard and being able to hear each other all day, what other people are working on, and being able to jump in and solve problems for everyone. And so I've been proved wrong that you can absolutely still have innovation and progress. However, it is way more fun when you can do pair programming literally next to somebody.
Yes. Yeah.
I still do miss that. And so hopefully 2 or 3 days a week in the office is a nice balance that I'll be able to strike in the near future. And if you're into that, listener, I hope you can too. And so so when you came to New York, originally you were living up by Columbia.
Yeah.
But then I guess the pandemic just kept dragging on, and you were like, well, I might as well just move to a nice part of the city that I really like.
Yeah, pretty much.
So what's that expected to be like going forward? Do you think that for the most part you'll be able to work from home? You'll go into Columbia a couple days a week maybe in the future? Yeah,
I've been going in like 1 or 2 days a week, and I think something like that will probably continue. I know before the pandemic for my lab, my advisor would sort of have people come in like at least 3 days a week or something, which was actually the same at OpenAI. We kind of had it was pretty standard if you wanted to only be in 3 days a week or something. That was good. So yeah, I think that's kind of my plan going forward. I'll just put all my meetings on one day, so I'll see everyone in person and go in for that day, and that's nice. And then doing research from home. Yeah.
That sounds great. All right, so let's talk about that PhD at Columbia a little bit more. So you decided, after making this amazing journey from Williams College to Apple to OpenAI, which is this place that you'd been hoping to work at for years. Amazing, you got that. But then you decided to leave industry and go back to academia, do a PhD at Columbia. I suspect, given what I know about you, and then even more so now that we're doing this interview, you could have had your pick of opportunities in industry or academia. So why did you choose to do a PhD, and why Columbia?
Yeah, it's definitely was a hard decision at the time. And I think there are a couple different factors, but the main ones were, first of all, that I kind of just wanted to move out of the Bay Area, and I was ready to try something different, and New York seemed like a place I wanted to live. And there were very few places doing work like what OpenAI was doing, and they were in the Bay Area. And there's also very few places that you could kind of do that level of research without a PhD also. So that it was
Right.
Yeah.
Right. Yeah, it's actually amazing. I hadn't thought of that, but it is actually incredible that, yeah, and it goes to show how in some ways, and we're going to get into this now when you talk about the PhD more and why you did it, but like in some ways it's kind of ridiculous
Yeah.
that a PhD should be a requirement for some jobs.
Yeah.
So it's amazing that OpenAI was able to see, okay, look, Melanie clearly has been studying lots of papers on her own. I know from my personal experiences with people that, you know, you, as I said at the very beginning, with the kind of the 5 levels of expertise with machine learning, you already are an expert. You happen to be now doing a PhD, being a grad student, but the way that you have sought out and studied on your own and the experiences that you've already accumulated, you already have more of the hard skills and soft skills that a PhD student is after than most people who graduate with those degrees have. So I guess my one point is that it's kind of it is ridiculous that you need PhDs for so many research jobs. And then my follow-up point is that it's great that OpenAI is open to having AI research engineers who don't have PhDs in situations like yours.
Yeah.
But then, it's, I guess, so then maybe part of where you're going with your answer is that it does still nevertheless open doors.
Right.
But you also, sorry, I'm probably not taking words out of your mouth, but I can imagine, like, I'd love to be doing a PhD now again. Because just to be able to take that step back and get support and be able to dig so deeply into topics and write on them. So please, you go.
that I think that was the second part is like, I think when I initially graduated from my bachelor's, I always thought of grad school as like a question of, do I need a PhD to do research? Like, just what you were saying. And what I found through being on the research team at Apple and then at OpenAI was like, no, I don't need the PhD. I can continue on this route. I can continue doing impactful research. But then I started asking, do I want it? And then that was a question of like, do I want to take 5 years to just learn what I want to learn, read what I want to read, explore areas I'm interested in, figure out what problems I really care about working on, and build my confidence as a leader in a research space and with leading research vision. And that then became really exciting and appealing to me, because I think what I was missing in my research experiences is I felt like I was developing really amazing technical skills and building really cool things, but I was very much coming up in the vision of sort of the senior technical leaders around me.
Right.
And I did feel like I needed to take a step back and consider, some of the really hard questions we've talked about even on this podcast, and just figure out my own mind around things and what I really wanted to be working on and what problems felt most important to me to kind of develop or to devote years of my career to. And
Awesome. Yeah, great answer. So in your PhD research, one of the concepts that you are doing work on is a cool concept of identity signaling. What is identity signaling, and how can it be applied to identify online misinformation campaigns, which is a really cool application?
Yeah, so I've been working with, thinking about misinformation and disinformation in news, and something.
Such a frustrating problem to watch happen in the world. We don't get political on this program, but believe it or not, I don't like disinformation as a data scientist. And it drives me crazy when every day there's something that happens. I would go into it, but I don't want to make the show political. It's a problem, and so anyway.
And my advisor also does a lot of collaborations between kind of social science and NLP, which I think is an interesting place as well. So something I've been looking at is thinking about how kind of personal identity comes into play in persuasive contexts online, and how we sort of pick up on things about each other in terms of sort of where we, what our core beliefs are, sort of like where we're positioned in the world, and how that shapes how we interact in a persuasive context. So like how we signal those things to each other, and then how we sort of use that information in a persuasive context. So the long-term goal of that is to think about identifying the intended audience between persuasive campaigns online, and being able to ideally automatically pick up on some of the markers of who things are targeted at.
Nice. Super cool. Yeah, very fascinating research. Are there other, so I'm imagining, I don't know exactly how Columbia PhDs are structured, but if this was my PhD, maybe this project, identity signaling to identify misinformation online, that might be one of my dissertation chapters. So do you have other leads on what your other chapters might be?
Yeah, something I've been talking to my advisor about beginning to work on is thinking about summarization of novel chapters. So again, going back to this piece of creative writing and also working with very long form text, which has always been interesting to me. So I think there's a lot of interesting problems there, both in terms of understanding like extremely stylized human language and also going back to what we were talking about before with long context and trying to solve the problem of like how do you give a model enough context that it could meaningfully process something like a book without when you're not going to be able to actually just feed in all of that text at this stage at least.
Nice.
So that's something I'm interested in thinking about.
Cool. So as a PhD student, what tools do you use day to day? And are they different from the kinds of tools that you were using as an AI engineer in industry?
Yeah, I think at a basic level, the tools are pretty similar, which is mostly Python and PyTorch and kind of associated libraries. I think when I was at OpenAI, we were using a lot more in-house libraries that we'd built up versus now I would probably use models from Hugging Face if I want to kind of access the same type of system. So
yeah, the strict non-Hugging Face OpenAI policy. No, those guys aren't doing anything interesting. Ignore them.
So that, yeah, just in terms of like the types of models, that's a little bit different. And then I think the biggest difference is the compute, and that's been kind of the most interesting thing for me to see both sides of. So when I was in industry, it was kind of very easy to access as many GPUs as you wanted for
at the
as
particular
long
places
as
you were working.
Yeah.
Yeah, a very unusual situation.
Yeah, that's true. So that was sort of what I was coming from. And now we have like one machine with 4 GPUs that I'm able to sign on to remotely, and like I'll check if anyone else is using a GPU and then I'll jump on one.
Right.
So that's, I think, yeah, just like where the compute is, how much there is, how you're accessing it is probably the biggest difference in terms of tools.
Right. Welcome to the real world.
Yeah.
With us commoners. So cool. And then are there any particular libraries or approaches that you're excited about? Hugging Face that is something listeners should definitely be checking it out. It's a really cool, they make lots of natural language models very accessible and easy to use.
Yeah, they have a great library. And I think that's the main one that I would mention probably in terms of like NLP tools. Yeah.
Cool. All right. And then, so we've talked about this already a couple of times. You did a computer science degree at Williams College, which is a prestigious liberal arts college in Massachusetts. And so how has your computer science background been helpful to you as an NLP-focused AI engineer? So we've talked about this a little bit in terms of the idea that as data sets get bigger, as models get bigger, having more computer science skills is helpful. But is there anything more specific than that?
Yeah, I think that definitely generally covers it. I think the main thing is maybe having an understanding of distributed systems and parallel computing at some level, because I think that was something, especially when I was interviewing at OpenAI, that I saw that was like a skill set that we would look for. And I think it's kind of uncommon that you're always tested on that, or like that's not as much part of the standard engineering suite. But I think that's something that it's hard to build if you're sort of just learning to program. That often doesn't come with an understanding of these distributed systems and how to work with them and how to engineer systems that are going to run in parallel across many GPUs potentially and pass information between them. So I think that's a big way that having that more like full computer science education helped.
Nice. Are there any particular distributed processing libraries that you tend to go to?
Again, I pretty much I mean, the main place I was using this was OpenAI, and we would pretty much write stuff in-house. So I don't have as much experience with kind of general libraries yet.
Nice, yeah. Well, I mean, it's one of the great things about the modern automatic differentiation libraries, like especially TensorFlow. I mean, that still is its strength today. So PyTorch, definitely way more fun for building your computational graph. But then I do quite like TensorFlow for distributing my operations. Mm-hmm. And for listeners who aren't aware of it, there's the ONNX library, ONNX, cool. The Open Neural Network Exchange. So you could design a model in PyTorch, and then if there was some distributed computing that you couldn't do in PyTorch, you can use ONNX to port your graph over to TensorFlow.
Yeah, that sounds really useful.
Yeah. Cool. All right, so here is a question that is my favorite question to ask on the program, but I save it only for special occasions so as to not wear it out with the listeners. Melanie, you were one of my special guests to get this one, because I think you'll have an interesting perspective on this. So thanks to ever cheaper data storage, ever cheaper compute, which we've talked about on the show, ever more abundant sensors everywhere, interconnectivity, allowing us to share papers on arXiv in real time, data modeling innovations that are constantly coming out at more and more labs around the world and being shared. Because of these forces, technology is advancing at an exponentially faster pace every year. Mm-hmm. And AI is playing a huge role in that. Mm-hmm. So is there anything that excites you about the future of things that could happen in our lifetime?
Yeah, that's a great question. I think a big one that we already talked about is the AI and climate space and efficiency space. And I think that's very exciting to me. With the flip side of this is way too much surveillance and tech involvement, which is a concern for me. But I think handled in an ideal way, there's just huge opportunities to have these very interconnected smart systems that just make pretty much every aspect of life way more efficient in terms of transportation, energy usage, just really everything in that space. So that's very exciting to me in terms of saving resources. And I think the other way is just having AI become a very kind of commonplace tool that everyone is able to use in different ways across tons of different research fields and outside of research too. And I think that's just very exciting to me, that it's something that enables everyone to do work better in whatever thing that they're doing. And I was talking to a friend who works in public health the other day, and she's a PhD student there. And I was thinking about how she does qualitative studies with huge amounts of interview data, and just thinking about the parallels there with some of the NLP techniques that we use to process natural language text. And so I think there's just so many cool collaborative possibilities that are going to become more and more accessible to everyone.
Totally. Yeah. And it's interesting for me to see more and more people growing up today, kids growing up today, they learn computing skills so that in so many different fields, you could do a creative writing PhD, but you might learn some machine learning and data science and computer skills because you're well, something really cool I could be doing is working with huge amounts of data and trying to do some automated inference. And so all kinds of traditionally liberal arts fields are being infused with these quantitative things, thanks to so much data now being stored and collected.
Yeah.
Very cool. All right, so I asked the social media before recording this episode if they had questions for you, and so I'm going to get to some of those questions. But before we do that, I noticed, as we've been recording here, that you're wearing a Whoop.
Oh yeah. Do you have a Whoop?
Yeah,
also?
I'm wearing a Whoop
nice.
as well. So there are lots of different kinds of fitness trackers out there.
Yeah.
Or activity trackers. And typically, Melanie, if you pick the Whoop one, it's because you actually, it isn't just to track steps or to get you to stand up from your desk every once in a while.
Yeah.
It's because you're doing some pretty rigorous exercise. So what's going on there?
I think that I would probably not fall into that camp. So I guess maybe I'm an atypical Whoop user. But I think for me, partly my friends had Whoops, and they were like actual college athletes and do exercise more often. But I think for me, it's actually about sleep mostly and like general wellness. So what I liked about the Whoop is that it's not like calorie or workout focused specifically. It's also kind of giving you your general like rest and recovery, and trying to sleep more regularly is something I'm working on in my PhD.
Yeah, it's been a big, I've completely changed my life as a result of having this. So the Whoop tracker, it's always on. That used to be their catchphrase. I don't think it is anymore. But you even to charge it, you put the battery pack on it. It didn't even come off your wrist when you were charging it. And so you get this data on yourself, your heart rate all day long, and your sleep. And yeah, so one of the things that changed for me dramatically is seeing how even just one beer, or especially 2 beers, my resting heart rate overnight can jump from 55 to 65. Yeah. And I cannot, there's like no amount of exercise I can do in a day that will cause my resting heart rate to go to 65. So it's like this, so it's suddenly seeing the data, it changes the calculations internally for me dramatically. Because before it's like, yeah, I enjoy beer, but do I enjoy it that much that I'm willing to do that to my body? And so, yeah, even things like I used to pretty frequently pull an all-nighter on work things. And that was a bad habit since undergrad. But it was like through my undergrad, through my PhD, like I was constantly like the night before anything major was due, I was guaranteed to be up all night working on it. Yeah. And I don't do that anymore. Yeah. So anyway, there you go. Well, that's interesting. And so actually part of why I asked, because I thought that maybe you would still be quite into athletics, is when I was researching for the show, one of the photos that came up of you was you like doing very high level track hurtling, maybe?
Oh, I did run track in college briefly. And so I like soccer and track. I do enjoy athletic pursuits, but I am more about the sleep with my fitness tracker. But yes, very good. All right. I was supposed to run a 10K and then I had to move unexpectedly. So that was my recent thing. Yeah.
Maybe next time you're on the show, you'll have a big athletics update for us.
Yeah, maybe.
All right. So let's move on to some of the good questions that we got on LinkedIn. All right. So we had a question from Nikolai Thompson, who's a data scientist at NTT, Data Business Solutions. And it was a question about bias, which we already kind of addressed in the program. So thank you, Nikolai, for that great question. And that was probably related to, so we now have Serge Massis, who responded to your question, Nikolai, online. He is now our researcher for the program, asking brilliant questions, and he already slotted in a bias question, but hopefully he addressed your thoughts. Another question here is from Bernard, who's a software engineer and a machine learning engineer. And Bernard is wondering if NLP could be involved in the future with non-verbal communication, so body language. So incorporating, I guess, a machine vision system in some way. And yeah, so there's some way that NLP can go beyond just verbal communication and be able to pick out patterns from non-verbal communication as well.
Yeah, I think that's a really interesting question, and it's not something I have worked on, but I've worked with some other researchers who specialize more in that, which I think is really cool. And I think it gets more generally at just cool ways that we're starting to combine information streams from multiple modalities. So I think DALL-E, like we talked about, is a great example of that, with how you can leverage both vision and language information to kind of augment the learning in both areas. So I think that's going to be really cool going forward. And that also connects to what I was saying with sample efficiency too, that as humans, we don't learn language just from kind of written words on a page. We learn it from seeing people interact. We're reading facial expressions. We're using all of that to figure out the meaning connected to that language. So I think what you're saying of incorporating more of these nonverbal cues could be really cool for teaching models more about how to read and interpret humans.
Nice. All right, and then we also had a question from Ted Hallam, who's also a machine learning engineer and host of the Data Canteen program. So his question was about how we can continue to improve NLP abilities in models more sustainably. So we've actually already talked about that one as well. So last question here is from David, who's into data visualization and he's into space. So he calls himself the space data guy. And I guess his question kind of follows along from his interest in space and science fiction, I guess. He asks, with few-shot learning, how close are we to a Star Trek universal translator level technology, being able to functionally decode new languages in minutes? So I guess the key thing here is, initially when I read this question, I was thinking, just having a system that can in real time translate between languages, we have that. But what he's asking about is a system that could somehow decode new languages in minutes. So that's a tricky one for you, Melanie.
Yeah. I think that would require some more fundamental language understanding than we're seeing at this point, which maybe gets into the structured learning that we were talking about earlier, of incorporating more kind of understanding of, is there a universal grammar or something that we're kind of encoding into these systems? So I don't know about that. I think the other direction is just like, I do think we have an issue with what languages are available online, which we were also talking about before. So there's a lot of types of languages out there that we just are not training systems on because they maybe are only spoken, or there are people who are using those languages are not also using the internet a lot. So I think that's probably the biggest barrier right now in terms of figuring out some of these more universal language components is not just hugely skewing towards the vastly overrepresented languages that we have.
Right. Cool. Well, thank you for those great answers, and thank you, audience, for the great questions. So we are near the end, Melanie. Do you have a book recommendation for us?
My current book that I'm reading is The Song of Achilles, which has been good so far. And then I am part of a book club with some friends, and we're going to read Say Nothing next, which is I haven't read yet, but came highly recommended to me and is about the Troubles in Northern Ireland. So
interesting.
I'm excited for that one.
Yeah, those are really interesting because they are in the very recent past. And up until recent events in Eastern Europe, I kind of thought that kind of violence was completely behind us. And hopefully by the time this episode is published, that situation has gotten a lot better, not worse. All right. Well, Melanie, I know you're not big into social media, but if our listeners are interested in being able to follow the amazing things you're doing, the next paper you publish, is there any way that they can be following that?
I think probably just my LinkedIn or Google Scholar are the best places.
Google Scholar, great choice. That makes a lot of sense. So set up a notification for Melanie's Google Scholar, or you can follow her on LinkedIn. Wonderful. Thank you so much for taking the time today. I've absolutely loved filming this. It's been so enjoyable doing it with you in person. And I'm looking forward to having the opportunity to work with you on something again soon. Well, I really hope we can get Melanie on the show again soon. I learned a ton from her and had such a fun time filming with her. In today's episode, Melanie filled us in on how autoregressive models like GPT-3 always generate forward from prior natural language inputs, while bidirectional models like BERT can get language context in either direction from a given word of interest. She talked about how GPT-3 doesn't need to be fine-tuned to perform a wide range of few-shot learning natural language tasks with greater than 50% accuracy, but that this fine-tuning via the OpenAI API can improve performance on specific tasks while also potentially reducing unwanted biases. She talked about how GPT-3 struggles with natural language inference tasks that may be overcome in the future by non-differentiable representations of information. She covered how renewable energy sources and sharing access to a smaller number of large models can mitigate the climate risks associated with large natural language models. She talked about how pair programming can be useful for sparking innovation. And she talked about how returning to academia from industry could be the right option for you if you're keen to explore different areas of data science freely and deeply over several years. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show,
the URLs for Melanie's Google Scholar and LinkedIn profiles, as well as my own social media profiles at superdatascience.com/559. That's superdatascience.com/559. If you'd like to ask questions of future guests of the show, like several audience members did of Melanie during today's episode, then consider following me on LinkedIn or Twitter, as that's where I post who upcoming guests are and ask you for your thoughtful inquiries for them. On that note, if you live in the New York area and would like to experience a Super Data Science episode filmed live and ask the guest questions in real time, then come to MLconf NY, which will be held on March 31st. That's MLconf, the machine learning conference, on Thursday, March 31st. In addition to filming a Super Data Science episode live, I'll also be doing a book signing session for my book, Deep Learning Illustrated. The first 10 folks in line will get a free copy generously donated by my publisher Pearson, and after that, I'll be signing them and giving them away at cost. This will be my first conference experience in over 2 years, and boy, am I ever excited about it. Hopefully, I'll get to meet you in person then. All right. Thank you to Ivana Siebert, Mario Pombo, Serge Massis, Sylvia Ogwang, and Kirill Eremenko for managing, editing, researching, summarizing, and producing another freaking incredible episode for us today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.